Okay, so let's review very quick what we said last time, and then let's start with the new content. So last time we said having pointers, you are just having in the memory a certain address, and inside you are saving another address, right? Which you are pointing to. So here I'm saving this address, and then I'm pointing to this address here, which is pointing to a certain variable, which is having a certain content, right? And then we gave like the two operators that we are working with. Here the AND operator and the asterisk, right? And here this actually to deal with the address, and this to deal with the value, right? And then we had this toy example, int data 50 equal 50, and then int asterisk p, and here I'm declaring a pointer, and here I'm just putting inside the pointer the address of data, right? Which we had this animation for having the pointer pointing to data. And then if I want to change the value from 50 to 100, I'm going to just have asterisk p equals to 100. This will change the value in data into 100. And then we had this example, and mainly this example trying to tell you, hey, remember, this is going to get the value which the variable is having, right? This will do the same thing, but using the pointer. This will get the address of the variable, right? This, again, will get the value of the address, right? Okay? And then this will get the address of the pointer itself, returning back. This, the address of the pointer itself. And this, the address that the pointer is holding, right? Which will point to. So again, from here, you can see that if I'm just writing p, so I'm getting the value which is stored inside b, right? Which is the address of var. Okay? But and p is getting the address of the pointer itself. Okay? This is very important to distinguish. And here, as I said, this is what you are going to get if you run this program. And again, 0x here means this is written in hex, right? Okay? And if you run this in your computer, you'll find that you have different addresses, because this is the memory of your computer, and this is the memory of my computer, and so on. Okay? And then we went over some mistakes, which is most of the time you are trying to assign something which is not the same as the other one, right? Like assigning an address to a value, or value to an address. Okay? So in this case, you are going to get an error. And then the last thing we was talking about is null pointer. So when you are dealing with a pointer, you can just declare the pointer, right? Once you declare the pointer, in this case, it's not pointing to anything, right? Which means that this is pointing to 0 or null, okay? And if you left it like that, when you run your program, as we have the run last time, you'll find that there's something weird happening, right? Why? Because I'm pointing to the memory, and then the compiler going to the memory to wherever you are pointing, and was not able to access anything, right? Which is last time you have done core or something like that. So every time you are initializing the pointer to null, you have after that to assign the pointer to a certain address, right? And again, if you forget to assign the pointer to a certain address, always you have to put an if statement to look if the pointer is assigned or no. And this is very helpful. Why? Because this will actually give you the insight that, hey, you forgot to initialize your pointer. So it's very, very helpful every time you are dealing with a pointer to have an if statement. If the pointer is pointing to null, please give me an error message, because the compiler is not giving you. If you remember last time when we ran the program, it didn't give me an error message. Okay? So in this case, it's very helpful to have an if statement, and this if statement will tell you, hey, you are having an error actually because the pointer is still pointing to null. Okay? Okay, so one very good practice when you are dealing with pointers, every variable or every pointer variable you are having, try to put something to indicate this is a pointer. So for example, I'm having a pointer and I'm naming it as, let's say, forward, for example, okay? Just any name, okay? Please try to do the following. Forward pointer. Put something to say, hey, this is pointer. Because while you are doing programming, you are dealing with a lot of variables. Until now, we are having, let's say, a program in the lab, and we are writing, let's say, 50 lines or something. But when you are dealing with a real program, you are dealing with 200 lines, 500 lines, and more than one contributing to it, not only you. So it's very important to have the comments to understand what others are doing, and also to have the standard way of writing the code so that each one can understand what is the others doing, right? Okay? This is why every time we are dealing here, when we started, I said, okay, when you are writing, let's say, a variable with 2 names, write the first all small, and then the second, the first letter is capital, right? If you see a code written, let's say, in Facebook or Google, you will find engineers there are writing it in the same way. And this is why we are naming it the standard way of writing code. If you went to an interview and tried to, they told you, most of the interviews are online interviews and give you compiler and text box and tell you, hey, write the code there. They will look at the standard way of writing the code. Are you writing it in a standard way? Because you are not going there to just work by yourself. You are working with others, right? You will share code with others. So they care about you are writing the code in the standard way or no. Okay? So this is a very important tip that every pointer you are using, try to put something to indicate that, hey, this is a pointer, okay, in the name itself. This is what I said. Every time you are dealing with a pointer, just try to make sure that it's not pointing to null. Yeah, I'm sorry. Yeah.
I've got a quick question. At our scale, like at the scale of this class, I realize that they're a lot more useful when you start writing super gigantic programs. But at this scale, what is the advantage of using pointers over using global variables? Because our programs aren't ever really that big.
Okay, very good question. Again, like, if you remember last time I told you, you will have a lot of questions regarding pointers. Until now, I'm not getting why actually I'm using pointers. But if we dealt with global variables, okay, and if you can see, until now, we are trying to avoid using global variables. And what is global variable? It's a variable which is defined outside everything, outside even the main function. This means that this variable will be overseen by the main function and any other user-defined function, right? So in this case, if you play with this variable within the main function, okay, and then you have the same variable in a user-defined function, most of the time you are not sure where this variable was modified and what happened with it, right? So this is why actually we try to avoid using global variables, because if you have it inside more than one function, I'm not sure which function modified this variable. Okay, and when change it and so on. So this is why we are trying to avoid to use it. But with pointers, I know that this pointer is pointing to this part, right? So every time it appears anywhere, I'm sure that I'm using it here to point to the memory to do a certain or a specific thing, right? And at the same time, I may, after that, change this pointer to point to another thing, which is not the case with global variable, right? So I can change, every time, I can change the pointer to point here, and then point here, and then point here, and so on. And after that, or today actually, we will see that you can release the pointer. After using it, you can say after a certain point, and we will see it today, you will say, okay, free the resources and free this pointer, will not be used anymore. We can play with that, okay? Is it clear now?
All right.
Okay. Yes, that's right. Yep. Yep, and this is our topic next Thursday. We will go with functions and how we deal with pointers with functions, and see actually how this is done, okay? And I will try to cover again your question at this point, okay? Okay, so the second thing here, just try every time you are dealing with pointers to have this check. If pointer equals null, give this error message or whatever, your customized error message, and finally exit 0 will just exit the program because you can't continue actually when the pointer, you already tried to assign it to something, to a certain address, and finally it's still pointing to null. So at this point, I'm just terminating the program to try to fix the error there. Okay? So this is very helpful one. And imagine that every time you are using pointers, that it's very helpful to paste this 3 lines there to make sure that the pointer is initialized. Okay? Okay, this is a very nice example, which is somehow confusing, but at the same time, we'll try to take you to see how pointers are assigned and how we can change a pointer from pointing to this variable to pointing to another variable. Okay, so let's start here. We have A initialized to 3, and A here is a regular variable, right? And then I have B initialized to nothing, just declared. And then a pointer P is pointing to A. So if I have A here and B here, I have a pointer B is pointing to A. Okay, and then a pointer Q is pointing to B. And this is a question: can a pointer points to a pointer? Yep. Yes. That's totally fine. You will put the address here, and then in the other pointer, you will put the address of the next one. Yes?
Why do you not need the and P for Q?
Because these two are pointers. So P by itself is an address. Okay? This is why I'm not putting here and. Very, very good question. Thank you. Yep. Yes?
So if that's the case, wouldn't Q go to A, not P? Because you're referencing the value stored in P. So then the pointer would really be pointing to A.
So let me draw the memory here just to try to get the point. Here is A, and here is B, and here is P, and here is Q. And let's imagine that we have here F2, F5, F7, FA. I'm trying to find like random numbers. It doesn't have to be in sequence, actually. Okay. So A will store 3. B is not having anything. And then P is storing the address of A. So this is F2. And then Q is storing. I think you are right. So here it's supposed to be F2, right? So instead of pointing here, it's supposed to point here. Thank you. Okay? So this is how we can see it in memory. And then after that, the next line, we have another pointer, which is called R. And this pointer is pointing to B. So I have here R, and this is pointing to B. If I have it here, R, and this is FD, and this is pointing to B, which is F5, right? Okay? And then the next value here, or the next line, printf enter value, and then scanf getting the value to R. And remember here, R is not having and before it. Why? Because it's already an address, because it's a pointer, right? So R by itself is an address. So I don't have to put the and, right? But if it is a regular variable, you have to put the and. Okay? Yes?
In our homework, the asterisk, like on declaration or initialization, was with the int, not the actual variable. So it's int star and then the variable name.
Uh-huh.
So is this formatting any different from that?
So int star and then Q. This means that Q is a pointer, right? And then after that equals, then this is the initialization. So what is the other part of your question?
So like the homework, is an int asterisk space and then Q.
That's totally fine. The space is not doing anything actually. Yep, yep. So you can write it in both ways. So you can write int or int. Both are 100% the same. Okay.
Would it matter if so if you didn't put a star right there, then it wouldn't be a pointer?
No, it will not be a pointer. If you just take out the star, this is a regular variable. Okay? Okay, so here scanning a value to R, okay, which will, in this case, will go directly to B, right? So here, after scanning, let's say, for example, we have here value 5 entered by the user, okay? So finally, I will have 5 here. Is this right? Because we are having the pointer R is pointing to B. In this case, we have the 5 here. And by the way, if you are in the exam, use any ways of these 2 ways and scratch that on the exam paper, just to let me know. I'm going to track what you are doing, actually, and finally we'll get what is the printf for each one or something like that, okay? So here, the printf, the first printf, is asking me to print A and B. So I have here 3 and 5. And then printf, percentage D, percentage D, percentage D, P, Q, R. So what will be printed here?
3, 5.
Right? And it's very easy to look to your map here. P is printing A, Q is printing A, and then R is printing B, right? And the values here are 3, 3, 5. All agree? Perfect. And then Q equals and B. By A, right? This is your map, and this is the sequence of the program, okay? So now I have Q is pointing to B, and then if P equals Q. Let's update our map here with the memory. So Q now is pointing to B, right? Where is Q? Q is here, pointing to B. So here, this is F5, right? So here I'm asking if P equals Q. Nope. Right? From the memory here, I can see that they are different. And then the next one, if Q equals R, yes. Print F2 and then /n, right? So here I will print 2. If asterisk P equals asterisk Q. Is this right? Nope. If asterisk Q equals asterisk R, right? Because both of them are pointing actually to the same thing. So finally print F4. So I'll print here 4. And the last one, if asterisk P equals asterisk R, print F5. Is this right? So that's it, okay? And by the way, we can name this as somehow exam question. It can be something like that. So in this case, you have to tell me from this example, hey, I know pointers very well, and you will never be able to trick me, okay, by answering this right, okay? So also, pointers can have arithmetic operations. What the meaning of that? You can increment a pointer, okay? You can subtract a pointer from a pointer. So all arithmetic operations can be done on pointers, okay? So by the way, if you started here to say val pointer equals to val pointer plus 2, okay? What the meaning of that? Since you are incrementing a pointer, you are dealing with memory addresses, right? Memory addresses are in bytes. So if I'm just adding 2 here, so I'm adding 2 bytes actually. I'm not adding just 2, okay? So every time you are dealing with incrementation of pointers, in this case, you have to make sure that you are dealing with bytes, right? So for example here, it was 2, 3, 4, 5, 6, 7, 8, 7, 0, okay? This is the address. Then from this statement, the new one will be this one, right? And as you can see here, we have 16, right? Which is 2 bytes are 16 bits. And this is why actually you have 16 added here, okay? Let me write that this is bits. And this is bits, okay? Also, I think we dealt with that before, but size of, it's just getting the size of whatever inside here, okay? So for example, size of double, this will give you the size of the double. If you remember at the beginning when we was dealing with int, double, and float, and all of these stuff, right? And was saying that, hey, this is the size. So the size of double is actually 8 bytes, right? Size of int is 4 bytes, right? Size of float, 4. Size of char, 1 byte, right? So inside your program, you can use this information actually. So if you look here, double array 10. Let me take your question first. Yes.
I was going to say, is that how arrays work then? Like the first part of an array, or an array is stored as like a pointer.
Hey, wait. Next Tuesday, okay? This is a schedule. So you are next Thursday. You are next Tuesday, okay? Okay. So until now, I'm trying to hide anything about like how we deal with pointers, how we deal with the strings. Waiting for the surprise on next Thursday or Tuesday. Okay. So here we have double array 10. Okay. And then size double. This will give you 8, right? And then size of array. This will give you 80, right? And then if you divide both of them, you can get the size of array itself. How many elements are in the array, which is 10 here, right? And this is a very good trick. If you, for example, ask the user to enter the array, okay? And after asking the user to enter the array, you want to know what is the size actually that the user entered without playing with whatever the user entered. How I can know that? By playing this nice trick. I know that he's dealing with doubles, and then I can get the size of array, the whole array, and finally I can divide both of them to get the number of elements inside the array. Okay? Okay, so until now we are dealing with something called static memory allocation. What the meaning of that? If you are saying int a equals to 10, in this case you are going to the memory reserving 4 bytes to store a, right? If you are saying int array 10, you are going to the memory reserving 10 consequence elements, right? Okay? And this is fixed. What the meaning of fixed? Once you compile, the compiler will actually have 10 elements. What if the user within the program want to expand the array? Never. Why? Because from the name here, this is static. Once you compiled, you can't change anything. Okay? But again, I have a user or a client who is saying, hey, I want to change the array size whenever I want. For example, I have an upgrade. Let's say I have a section which is have 20 students, and then 2 other students came. And you already have the array size is 20. What I have to do, right? So in this case, I will say, I have to do another program and run it again and do everything again, and that's it. This is the only thing I have since I'm using static memory allocation. Okay? So this is the main limitation, that you can't change the memory allocation after compiling your program. And this is why we will think about, hey, can we use another thing which is somehow dynamic? Can I play with the memory within the runtime of the program? Not before compilation. Within the runtime itself? Yes, you can. By using what is called dynamic memory allocation. And here is one of the advantages of using pointers. Okay? As I said, we are having a series of lectures, right, until next Thursday. And I'm going to answer some questions related to why actually we are using pointers. So this is one of the advantages of using pointers. What is this? This is actually if you want to have an array, okay, of 10 elements, and then after that, you will tell the user, hey, do you want to change the size of the array? The user will say, yes, I wanted 20 elements. Okay, here it is, 20 elements. Within the runtime, you will ask the user within the runtime, do you want to change it? Yes, okay, let's change it. And so on. So you can play with the memory within the runtime, not static as before. Okay? So here, this is the main comparison between static memory allocation and dynamic memory allocation. In static, you can't change anything within the runtime, right? In dynamic, no. Within the runtime, you can play with the memory. You can expand the memory, whatever you want. Okay? An example here is an array. An example here is linked list, which, again, we will know about linked list next Tuesday. Okay? So let's here try to see what are the functions that are used to have the functionality of dynamic memory allocation. First one is called callocate, okay? And this is a function used to allocate array of elements or array of memory. So in this case, if you are using callocate, you are just having to allocate array of elements. Mallocate is doing the same thing. It's giving you a block in the memory which you can put your array elements. Reallocate, here's the trick. Reallocate within the program, you can change the original allocation to a new one. Okay? So I allocated 10, and then in my code, I will say reallocate, and this reallocation will be based on the user input. Whatever the user will input, I will just reallocate the memory. Okay? And how this is happening, it's, let's say in callocate, I allocated 10 elements. Okay? So in the memory, element 1 until element 10. Okay? Then reallocate, let's say I'm going to reallocate 20 elements. Okay? So what will happen the following? You will expand here another 10 elements, right? Or elements, right? Is this right? No, this is not what happened. This will never happen. The compiler will go to the memory, find a free 20 elements, and copy this here. And then expand the other 10. Why the compiler is doing that? Because, again, every time you are accessing the memory, you are getting any random allocation, right? You are not getting the first address, and then the next one coming is getting the next address and next address. So if the compiler assigned for you 10 elements in the memory, okay, and then after that you said, I want to expand these elements into 20 elements. So the compiler is trying to find, okay, let's try to find a free space for 20 elements. And copy this 10 elements, and then discard these 10 elements away. And finally, I will have the 20. Yes?
I think it's generally smart enough to not overwrite stuff. So if you have an array of 10 and there's something at the 11th spot, they're not, and you change the array to like 15, it's not going to overwrite.
This is the reason. I'm not overwriting anything if I have something after that and I want to expand. This is why I'm taking it to another memory location which is having enough space. Okay? Okay, so until now, callocate and mallocate are almost the same. There is a slight difference between them, and we will see it. Reallocate is reallocating memory locations, which if you want to expand your memory locations. And finally, free is freeing out the memory. So let's say I reserved 1,000 elements or memory locations in the memory. Okay? And then after using them, I want to release the memory for any other variables to use this part. Why we are using this? Why we are using free? Because, again, 50 years ago, the computer wasn't that powerful. The memory was limited. So this is why let's put some variables here. Play with them. Did you finish playing with them? Yes? Erase them, please, and have another variables. And erase, have another variables, and so on. Okay? But we're still using this until now. Why? Because memory, microcontrollers are not having that much memory, right? So again, microcontrollers, we are playing with that. Putting or reserving a certain part of the memory and working on it. After finishing, destroy it. Destroy it using what? Using free. Okay? Is it clear? Okay, so now let's see the syntax for each one of them. So the first one, mallocate. This is the function, mallocate, and then number multiplied by size of int. So for example, if you want an array of 10 elements, you want to reserve an array of 10 elements, you will actually have mallocate 10 multiplied by size of int if the elements are ints, right? So in this case, you will have in the memory 10 memory locations will be reserved. You will not put there anything. You are just reserving them. Using what? Using a pointer. So the pointer is reserving 10 elements, and that's it. Okay? callocate, it's the same thing, which here you will have, again, this is 10, and this is size of int, so you will do the same thing as above. Reallocate, if you want to reallocate, the first thing you have to tell me what actually you want to reallocate. So you have to give the pointer name, right? I want to reallocate memory to this reserved part. So you have to give me the pointer name. Here, why you didn't give the pointer name? Because you are still at the beginning. You are creating, right? So this is why you are not giving inside the pointer name. But here, I'm reallocating. So tell me what you want to reallocate, right? So this is why I'm asking here for the pointer name and then number multiplied by size. Okay? And again, what is the number? This is the number of the whole elements. If you want to expand to 20, so this number will be 20. Okay? And then finally, if you want to destroy everything, destroy the 20 memory locations, use free and then pointer name. Okay? So the syntax is very straightforward. Okay? Starting mallocate, callocate, and then reallocate, and finally free. And this how you are doing that in the memory. So here, if you used mallocate, and this is how you are going to use it, mallocate 5 multiplied by size of int. Here in the memory, the pointer will reserve here 20 bytes. Why 20 bytes? 4, size of int is 4 multiplied by 5, which is 20 bytes, right? Okay? Again, this is 4, size of int. And then multiplied by 5, and finally, I will have the pointer reserving 20 bytes in the memory. And again, I'm only here reserving. I didn't put any element. I'm reserving. Okay? Is it clear? Okay, so this is for mallocate. For callocate, you'll find that, again, I have here callocate 5 and then size of int. And here it will reserve 5 memory elements. Each one is 4 bytes. And here, this is again 20 bytes. Okay? What is this? This is what we name as casting. So casting here is used just to say that, hey, this pointer, please make sure that this pointer is an int, declared as an int. Okay? So for example, at the beginning, you can declare your pointer as void. That's totally fine. But after that, you have to do casting, which is changing this from void into an int. But here, it's actually useless. It's not doing anything. Then free. For example, if you used callocate, you would have these free memory elements, right? Reserve it for your pointer. And then if you used free pointer, this pointer, the pointer name, free, this will take everything here to the trash and release the memory again. So it's free for any other variable to use it. Is it clear? OK. So let's now jump to a quick example here. And I started here by declaring a pointer. Declaring only, this pointer is not pointing to anything, right? Just pointing to null. And then the next part, I have pointer. And then mallocate size of int. So size of int, and then I don't have anything written, any number written, so I will just reserve 4 bytes in the memory, right? And I will just go to any memory location, any free memory location, and I will just have this reserved for this pointer, okay? And then after that, I will have this address covered to the pointer, okay? And then here, if I have print the pointer, this will print actually this memory location, which is 5. And then finally, if you have pointer equals to 100, this will change the pointer address or the pointer value to 100. OK, so let's see now an example. A real program that is dealing with mallocate or callocate and see how the memory is allocated. So I think it's somehow small, but let me go with that here. Starting with the main function, and then int num I asterisk pointer, and then sum equals to 0. Okay? We just want to have array elements and add all of them. That's it. Okay? but we will use dynamic memory allocation. So after that, asking the user to enter the number of elements. Hey, remember, here, when I started, I didn't declare any array, right? I didn't declare any array. If you look here, any array? Nope. I'm just declaring here a pointer, which inside I will have the array. But who will decide the length of the array? It's not me. I'm not writing a of 10, for example, right? It's the user. So here, if you can see, I'm asking the user to enter the number of elements, which is here num. And then pointer, which is this pointer, will equal to mallocate num that the user entered, right? Multiplied by size of int. So in this case, I didn't decide in my code what is the length of the array. Who decided? The user, the client, right? It's my class. So in this case, I'm going to write, actually, it's 165 for num, right? If I'm using this program with another class, the class instructor will decide this is 51, which the number of students there. So in this case, now this program is dynamic. It's not fixed to a certain class, right? So every class you are using this program, you are not going to change the code. It's the same code. And this is why dynamic memory allocation is very important, okay? And then after having this, I'm going to have in the memory, okay, a certain length based on num is reserved for this pointer. So what's the next step? Oh, it's the very important step, which is if anything failed here, you will not get an error. If the pointer didn't get the memory locations assigned to it, you will not get any error. So in this case, you have to have this check. If you remember in previous slides, we have, hey, please put this check every time you are dealing with a null pointer, right? So in this case, here you have a null pointer, right? And here you have the check to make sure after assigning the pointer if everything went right. Is it clear? Okay, perfect. Then what is the next step? The next step is to ask the user over here to have for loop, okay, just to enter the elements, and then scan the values to the next allocated memory, and here scanf %d, and here pointer plus I. Wait, what is this? As I said, the pointer can be incremented, right? As we said, pointer can be incremented. So what is happening here? The following. Let's give a small example here that the user entered here num as 10, okay? So this pointer will point here, and then you have 10 memory locations. Let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Not okay, sorry. Now it's okay. Okay. So here, this what will happen after this step. Okay? And the pointer here, let me write the pointer, will point here to this address, which is, let's say, FA0. Okay? And then the next address will be FA1, FA2, FA3, and so on. 4, 5, 6, 7, 8, 9. So when we are reserving arrays in the memory, we are just having them in the same sequence. So starting from whatever the address here and counting the number of elements. Okay? So what I'm doing here is the following. I'm writing here, where, here it is. This part, let me write it here. This part is saying the following. In the first loop, it will have FA0 plus 0. Where is this address? Here I equals to 0, right? The first loop. Where is this address? First one here, right? Okay. What I'm going to do, I'm actually scan from the user a number, and we'll put it in this address. Can you see how the program is going? Okay. And then the next step, what is the next step? The next step, actually, you will have FA 0 plus 1, right? And then what will happen here? I will look at this address now, right? And scan from the user, okay, a value, and I will put in this address. And so on. So in this case, you have the pointer pointing to the first element, right? And then you are incrementing a for loop just to go to the next address, the next address, the next address, the next address. Okay? So in this case, you are going to all addresses here. Yes?
When you increment by 1, doesn't that increment by 1 byte?
Yes, I'm just having here a toy example, but let me write it in this way just not to confuse anyone. So here, this is 8.
But integers take up 8 bytes, right? Or 4 bytes?
Yes. So in this case, every time you are going with the for loop, you are having I added to the pointer, right? And then jumping to the next element, scan it, jump to the next element, scan it, right? And then the next line we have is here, sum plus equals to pointer plus I. So now, remember, here there is no asterisk, right? So we are dealing with address. Here there is asterisk. This means that we are dealing with values. Can you see the difference between the two lines? Here, I'm going to this address. Here, I'm going to this address to get the value from there, right? So whatever the user will enter, I will take it to have a sum or sum all the elements there, okay? So this is very important. Again, if it is clear here, scanf, %d, pointer plus I. I'm dealing with an address here, right? And then here, sum plus equals to pointer plus I, but all have asterisk. This means that you are getting the value from there, right? So if I'm at FA0, so let me write it here. Let's say the value here is 7, and here 14, 3, 5, so on. So in this case, this will give 7, right? And then if I have this will give 14, and so on. Okay? Is it clear? And after doing that, I will just going to print the sum. And the last step here, free pointer. This means that when you say free pointer, okay, so let me take this here. And here are the 10 elements, starting from 0 until 9. Once you say free, this will be destroyed and released back to the memory. Okay? Yes?
Will it not be destroyed if you didn't put that and the program just ended? Or?
Yes, it will not be destroyed, and it will stay there, okay, until you terminate the whole program. Okay. Okay, so what if we want to reallocate the memory? So this program here, I'm just having nums equals to here the casting as float, and callocate 5 and size of float. Okay, so here callocate is just having allocating 5 elements in the memory. And then here, for I equals to 0, I less than 5, I plus plus, nums of I equals to 2 multiplied by I. So initializing the memory elements by a certain values here. And then, now here's the next step. Nums equals to reallocate nums 10 multiplied by size of float. Okay? So in this case, here it was 5. Now it will be 10. Right? So again, this here, the first one, from 0 to 4. The second one from 0 to 9 using reallocate. Okay, so let me give you an example to show what is the main difference between callocate and mallocate, and we will finish. Just only 1 minute and then we will be done. So here, if you look at this example, I have allocation here, okay, using mallocate and then printing directly without having any initialization. I didn't do any initialization, okay, and printing directly. And here I'm having the array again, but reserved using callocate and printing directly, okay. So let's try to see what is the difference between these two prints. As you can see, the first one is giving 928. The second one is giving 0. So what is the main difference between mallocate and callocate? Mallocate allocate the memory location, okay, without initializing it. Callocate allocate the memory location and initialize all elements to 0. This is why here we got a garbage value from the memory. This was a value there in the memory. Did you put there? No. It was there by itself. So it's better actually to use callocate to make sure that all elements are initialized to 0. If you didn't use it, you will get any garbage value from the memory, and that's it. As we got here, if you remember at the first point here, we didn't do anything except allocate the memory and then print, and we got this value, right? Okay? Any question? Okay, so again, as I did the last time, I will post the video for this class on YouTube, and again, if you can revise or if you want to revise anything from it. Thank you very much.
Do you have a second to answer a couple questions?
Yes.